So first, let's look at the cloud-based software. Mm, Are you all able to see the screen? Engineering software products, cloud-based software. Yeah, it's available to you. Good. So the cloud-based software, uh, you have came across or you already know about what this term cloud is actually. So nowadays everyone is using cloud, accessing cloud for storing purpose, or you can also run your code or some type of services in the cloud as well. So cloud-based servers are the virtual servers, which means that they are implemented in software rather than the hardware. So some of the customers can access these cloud servers from their own computers or other network devices such as a tablet or a TV or some other mobile devices as well. And these cloud servers can be started up and shut down as the demand changes. You are also able to rent a server and install your own software, or you may pay for access to the software products that are available on the cloud. So there is one term called cloud-based computing, which is also called software as a service. The short form is SAAS. We are going to look into other terms and more details about this software as a service, the various types of cloud-based computing terms. So this is one of the term which allows the users access to software applications that run on shared computing resources. So what are the shared computing resources? Again, they may be processing power. Some of the examples are processing power, memory, or disk storage, and they all are can be shared through the internet. We are going to look into more concepts like the SAA is the software as a service. We will look into other terms as well in this chapter. So these are the three terms, some of the characteristics of cloud software. The scalability is actually something that reflects the ability of your software to cope with increasing number of users. It has something to do with the load management aspect. So if the load on your software increases, your software automatically adapts to some extent so that the system performance and the response time is maintained. Is there anyone of you having any issue? Um, because I hear some prompts of someone leaving and joining again. If you have any issues, let me know. Then comes the next characteristics is it's about elasticity. So it's related to the scalability, but also allows for scaling down as well as scaling up. So that is, you can monitor the demand on your application and add or remove the servers dynamically as the number of users changes, or there may be a demand change as well. And the resilience means that you can design your software architecture to tolerate different types of server failures. Then the benefits of using the cloud for software development. So some of the benefits are cost, the startup time. So you don't have to wait for hardware to be delivered before you can start work. So using the cloud, you can have servers up and running in a few minutes or seconds also. Then server choice. So if if you find that servers you are renting are not powerful enough, you can upgrade to more powerful systems, or you can add servers based on requirements as well. Then comes your distributed development. So if you have a distributed development team working for different locations, then all team members have the same development environment and can share all the information, okay, through the cloud software development. Um, then your virtual cloud servers. Um, so what is a cloud server actually? A cloud server is a compute server that can be virtualized. So what does it mean? It can make its resources accessible to users remotely over a network. You must have heard about virtual machine. Okay, so that is one type of example for this. So cloud servers are often referred to as virtual servers, virtual private servers, or virtual platforms. So if you want to find out a difference in between um, the virtual private server and cloud server, so the main difference is that a traditional VPS, that is the virtual private server, and the cloud server are similar in their setup. Their setup is mostly similar, but main difference is the way each server is deployed and managed. So in the virtual private server, it's hosted in one single server, while the cloud server is a virtual partition consisting of multiple physical servers for maximum scalability and high availability. Okay, that's why we are more inclined towards the cloud server. There are other explanation about the virtual cloud server as well, so I'll suggest you to check them out in the book. Let's look at the implementation of virtual server as a virtual machine. What does it mean? Your virtual machine, so one of the example could be your virtual web server or virtual mail server. So here in the figure, you can see there are two types of virtual servers, web server and the mail server are there. So virtual machines running on a physical server hardware can be used to implement the virtual servers. The details are basically complex, but you can think of the hypervisor here, this layer. It provides a hardware emulation that simulates the operation of the underlying hardware, this hypervisor. And several of these hardware emulators share the physical hardware and run in parallel. The advantage of using this virtual machines is to implement the virtual servers is that you have the same hardware platform as a physical server, and you can therefore run different operating systems in terms of one for this guest operating system. You can run different operating systems, maybe Linux or Windows or some other operating systems on virtual machines that are hosted locally in the same computer. So here in the figure, the Linux and Windows can run concurrently on separate virtual machines. And this setup helps to run software that is available for only one particular operating system. Okay. Uh, so this is your virtual mail server. One example is the Outlook, Microsoft Outlook, and the Apache web server is considered for the virtual web server. So as a web server, you may not have more idea about it, or you may have. Um, so as a web server, Apache is responsible for accepting the requests you have seen, like in a if you have taken the web development class, you already know what is HTTP, what is a URL. So Apache is mostly responsible for accepting the HTTP request from the internet users and sending them their desired information in the form of files and web pages. So that is what your Apache web server is. Then next, there is another one type of virtualization is container based virtualization. So what is this actually? If you are running a cloud based system, okay, and if there are many instances, there are so many multiple applications or services, and which may use the same operating system, they have to use the same or share the same operating system, then you can use a type of virtualization technology which is called container based. Let's look at the figure. Yeah, it's here. Figure 5.3 in the slide. So this container based for virtualization uses the kernel on the host's operating system to run the multiple guest instances. So we can run multiple instances, and each instances or containers, and each container have its own root file system, process, and network stack. So what are those actually? So containers are different from the server virtualization. It's that the virtualized architecture here emulates a hardware system, and each virtual machine can run an OS in an independent environment and present to the application through abstraction. And here, actually, before in the hypervisor, which was responsible for hardware emulation, so here the VMs can require various resource overhead, memory, disk, and network input output, because the virtual machines run an operating system independently. And at here, for each individual user for different types of requirements, they are using their own application software and server software in the form of different containers. And those in that architecture, for managing the container, there is a layer called container manager, and the operating system, it is organized in certain way that the operating system, it can run in any type of operating system. You can use Linux, you can use Windows. You don't have to run them independently in different virtual machines that we saw in the previous case. And they also share the server hardware as well. Next, there is a Docker. So what is this Docker? This is again related to the container based virtualization. So Docker is an open source containerization platform. It enables the developers to package the applications into containers. Okay, so the structure is actually like standardized executable components combining the application source code. It will also have the operating system libraries, and also have some dependencies required to run that code in any type of platform or environment. That it does have a different type of architecture as a whole. Let's look into that in this figure here, the Docker container system. So Docker is a container management system that allows the users to define the software to be included in a container as a Docker image. And it also includes a runtime system that can create and manage containers using these Docker images. So let's look into um, the terms that we see here in this figure. Docker client, hub, daemon, images, containers. So Docker daemon, this is a process that runs on a host server and is used to set up, start, stop, and monitor the containers, as well as building and managing the local images. These images. Um, and the Docker client is a software used by the developers and system managers to define and control the containers as a whole. The Docker files, they define the applications, runnable applications or executable applications, which are the images, as a series of setup commands that specify the software to be included in that container. And each container must be defined by a specific Docker file. Then image. A Docker file is interpreted to create a Docker image, and it's a set of directories with specified software. And images are set up to be a runnable Docker applications. Then comes Docker Hub. This is a registry or a storage space of images that can be created, and these may be reused to set up the containers or as a starting point for defining the new images based on requirement. Um, and the containers are actually the executing images. The images is loaded into a container, and the applications defined by the image starts the execution, and the container may be moved from one server to other server without modification, and can be duplicated among all the different servers as well. So in this type of setup, you can make changes to the Docker container. You can modify different files, but you need to pay attention to the commit. Like every time you make a change, you have to save it properly so that that proper save is properly committed and stays there. Okay, so some of the explanations about those. Um, then benefits of containers. So the containers, they solve the problem of software dependencies. You do not have to pay attention to the libraries management, and it provides software portability. And the Docker type of container can run on any system or cloud provider wherever the daemon part is available. Then there is a term DevOps. Okay, so it also the container based architecture, they simplify the DevOps mechanism. So this is an approach for the software support where the team who will be developing the software, they can also support the operational software. They can also provide the support as well along with the development. So nowadays, this DevOps concept is actually used and adopted in all the major software companies. Next, so in the starting, I mentioned about the software as a service, SaaS. So in the everything as a service, um, as a software product for all software product developers, there are three levels where everything as a service is most relevant. We are going to look into them: the infrastructure as a service, platform as a service, and software as a service. We will look into more detail about all these services and what are their significance as well. So in the infrastructure as a service, the cloud providers offer different kinds of infrastructure service, such as compute service, a network service, and a storage service that you can use to implement different virtual servers. And here the cloud provider manages the IT infrastructures, and those infrastructure can be in the form of storage, server, network resources. Okay, and they can deliver them to the subscriber organization who will subscribe for that particular service through virtual machines available throughout the internet, as this is a cloud based concept. So this IaaS can have many benefits for organizations, such as potentially um, uh, making the workloads faster, easier, more flexible, and more cost efficient. Then your platform as a service. Here, you use the libraries and frameworks provided by the cloud provider to implement your software. These provide access to range of functions. They include the SQL or NoSQL databases. Your Facebook actually uses the NoSQL databases. The platform as a service, PaaS, is a complete development and deployment environment in the cloud with resources that enable you to deliver everything from simple cloud based applications or apps to sophisticated cloud enabled enterprise applications. From the simpler applications to most complex enterprise, they can provide enterprise solutions as well for all the different applications. Then comes the software as a service. Here, the software product runs on a cloud and is accessed. We have already looked into it in the beginning. So, it's accessed by users through web browser or a mobile app. I have already mentioned that. And it allows the users to connect to and use the cloud based apps over the internet. So, some of the common examples you can relate to are the email, various office tools like your Office 365. If you are using the OneDrive, Microsoft Office 365. So, this software as a service provides a complete software solution which you purchase and whatever is needed, like a pay as you go basis. Whatever you need, just pay for it. You don't have to pay extra. Okay. So you can purchase on a pay as you go basis from the cloud service provider. Okay, so here the management responsibilities of the IaaS, PaaS, and SaaS. Um, an important difference between the IaaS and PaaS is the allocation of the system management responsibilities. So this figure here shows who has the management responsibilities for all the different types, such as your software as a service, infrastructure as a service, or platform as a service. Okay. So the infrastructure, this is left side is your for IaaS and right side is for your PaaS. So if you are using IaaS, you have the responsibility for installing and managing the database, the system security and application. If you use the PaaS, you can develop responsibilities of managing the database security to a cloud provider. And in your software as a service, SaaS, assuming that a software vendor is running the system on a cloud, this vendor can manage the application and everything else is the cloud provider's responsibility. Mm, and this figure shows actually the infrastructure or the architecture, not the infrastructure, the architecture of the software as a service. Uh, the software products are delivered as a service all the time, and rather than installed in a buyer's computer, they are always delivered as a service. And if you deliver your software product as a service, you can run the software on the servers which you may rent from the cloud provider. And customers, software customers, don't have to install the software, and they can access the remote system through a web browser or a dedicated mobile app. And the payment model for the software as a service is usually a subscription model. Users may pay monthly fee to use the software rather than to buy it outright. So, so here the slide briefly tells us about the benefits of the SaaS for the software product providers. Uh, so you can briefly look into the various benefits related to cash flow, update management, deployment, payment flexibility, data collection, and other aspects. Next, some advantages and disadvantages. Um, For the software as a service for the customers, what are the advantages and disadvantages? You can have access in all the portable devices. No upfront costs are there for the software and servers. You can have immediate software update, and management costs are low also. Software management costs are low also. But these are some of the concerns or the disadvantages as shown here, that is related to the software as a service. So here some data storage and management issues for the software as a service, some regulation issues. So depending on different countries, what are the various guidelines involved? So based on that, the SaaS may have some sort of storage and management concerns. There are data transfer issues, security and exchange issues as well. Then design issues. There are four design issues. We are going to look into the more detail about the multi-tenant and multi-instance. So, but first, let's see what is this local remote processing. Uh, a software product may be designed so that some features are executed locally in user's browser or mobile app, where local execution reduces the network traffic. It also increases the user response speed. So this is useful when users have a slow network connection, and the local processing also increases the electrical power needed to run the system. Then your authentication, if you set up your own authentication system, like authenticating means what? Suppose you are logging into a bank account, you need your ID and password on, or if there are some security questions that you have enabled, you need to also look into all those services to properly be processed to log into our account or properly be authenticated. So if you set up your own authentication system, you have to remember another set of authentication credentials, the ID, password, security questions that I just mentioned. And many systems allow the authentication using Google's users Google, Facebook, or LinkedIn credentials. You may have, came across or felt it in some way while having or going through some sort of authentication for any type of websites. For business products, you may need to set up, in some instances, you may need to set up a federated authentication system. So, which delegates the authentication to the business where the user works, like the way you are authenticating or logging into your MyComnet or banner. So, without your net ID, the CSU provided net ID and other credentials, you may not have access to the MyComnet or the banner. Hope you can relate to that. Then your information leakage. So if you have multiple users from multiple organizations, a security risk is that the information leaks from one organization to another. And there are various ways, different ways that it can happen, and you need to be very careful in designing your security system to avoid this. Then comes your multi-tenant and multi-instance database system. In a multi-tenant system, all customers are served by a single instance of a system. That is also called as a multi-tenant database. But in instance system, a separate copy of the system and database is made available to each user. So that's the main difference in between multi-tenant and multi instance. Let's dive into more details about the multi-tenant systems. Uh, a multi-tenant database is partitioned so that all the customers can have their own specific space, and they can store their own relevant data and access their own data. Um So there is a in this case, there is actually a single database schema defined by the software as a service provider, customer provider, and that is shared by all the systems user. Let's look into this figure here. So here, the items in the database are tagged with a tenant identifier representing a company that has stored the data in the system, and the database access software uses this tenant identifier, this T516T632, this first column, all these tenant identifiers, to provide logical isolation. That means that users seem to be working with their own database, own relevant data. So this actually illustrates the multi-tenant database system situation using a stock management database table. And this first column, tenant identifier column, is used to identify each record in this database, which is exclusive to that particular tenant. The various advantages and disadvantages of multi-tenant database. So resource utilization. So provider can have control of all the resources used by the software, can optimize the software, and make effective use of resources. Um, in terms of security measure, it is more secured, and therefore it is likely to have fewer lesser security vulnerabilities than the standard database products. And it is easier to update the single instance of software rather than multiple instances. The disadvantages are it is not that flexible. So customers must all use the same database schema with limited scope for adapting the schema to individual needs. Then there are security and complexity concerns as well. Mm. Next, your multi-instance database. Your multi-instance database, the SaaS, software as a service solutions, are mainly built on two types of architectures. The multi-instance on one side and multi-tenant on other. So tenant actually refers to your team or organization of customers. In your multi-instance architecture, several companies will run their own separate instance of the application with their own database, and each company will therefore have an access to its data separately, totally separately from one another. But as I we saw in the tenant multi-tenant architecture, if there are several companies, they will use a single instance of application, unlike your multi-instance architecture. Hope you understood the difference in between multi-tenant and instance. There are basically two types of multi-instance systems. So the virtual machine based multi-instance systems are the multi-instance system where the software instance and database for each customer runs in its own virtual machine. Okay. And there is another one, container based multi-instance system, where each user has a separate isolated version of software database running in a set of containers. Then the advantages and disadvantages, you can look into it more thoroughly in the book. Um, the advantages and disadvantages associated with the multi-instance database. Then, when choosing a specific type of data organization, what are the various factors that you need to look into? These are some of the factors you have to pay attention to. Target customers, transaction requirements, about the size and connectivity of database, and then the interoperability aspect of database and the structure, whole system structure. These are some of the questions that you need to ask when choosing a specific type of database organization. Which type of organization will actually suit your purpose. Next, there are two terms, scalability and resilience. So, based on this, we are going to look into this figure. So, let me first go through this. The scalability is a measure of systems' ability to handle varying amounts of work by adding or removing resources from a system. Okay, and resilience means designing to withstand failures. A resilient application is one that continues to function despite failures of the system components. Uh, so here, resilience mostly relies on redundancy. So if you have replicas of software, uh, or data that are maintained in different locations, if the database updates can be mirrored so that standby database is a working copy of the operational database. And in this figure here it shows a standby system where data in different locations A, B are synced, will be in synchronization with each other, so that there is only a minimal delay in bringing up the new system. And if there are two database, there is a database mirror will be supported. And if location A and location B, they are using their own copy of the database, then the system will monitor continually checks in the system status, and it can switch to the standby system automatically if your active system fails in one location. By this, it will provide resilience to the whole system. Okay, so cloud platform. Uh, the cloud platform refers to the operating system and hardware of a server in an internet based data center. Okay, and it allows the software and hardware products to coexist remotely and at scale. Um, so, actually, there are various types of cloud platforms, and there may not be a proper single one which will work for everyone. There are different models, types, and services available to help meet the varying needs of the users. So, there is a public cloud. Okay, public cloud platform are third party providers that deliver computing resources over internet. So one of them is Amazon Web Services, you may have heard about it. Your Google platform, there is Alibaba, Microsoft Azure, uh, and IBM's Bluemix. Then there is private cloud. So private cloud platform is exclusive to a single organization, and it is usually an on-site data center. um, and some of the example are HP data center, there is Ubuntu. These are some of the example of private cloud. Then there is public private, there is another one hybrid cloud as well. So this is a combination, hybrid cloud is a combination of public and private cloud platforms, and data and applications move seamlessly between the two, the private and public. And so to some extent, as the hybrid cloud refers to mixed computing storage services environment are made up of such type of infrastructure, private cloud services, and some of the examples are your Amazon Web Services. To some extent, it can come under the hybrid cloud and the Microsoft Azure as well. So for cloud platform choice, there are some issues, technical issues. There may be load issues, predictability of load, resilience issues, or what are the supported cloud services, and some privacy or protection issues as well. Then here, some business related issues for the cloud platform choice. More details could be found from the book. So with this, we conclude our chapter, that is our cloud based software. You can find the presentation as I mentioned. Um, here is your presentation, cloud based software. Now, before getting started with the next one, the microservice architecture, let me first take you through the chapter content. Here, see, there are two, for the 2 weeks, there are two different overviews, but let's not go through that because today only I just opened or made available all the homework that you need to complete. These are the useful links. I think I have already mentioned this. Okay, for UML, additional helpful links. If you want more details about it and you are not satisfied with the content of the book or the presentation, you can look into more details through these all links, and this may help you with your discussion, participation, or the test as well. So some videos are included for creating activity diagrams. Presentation is also provided for the activity diagram with samples. I have already shown you some of the samples as well. So go through all these videos, look into the examples. Then here here you will find the activity diagram assignment for the student management system. So some of the activities could be how to log into the system, how to add student courses, manage course, add faculty, etc. So based on all these activities, if you have something in your mind, other additional activities, feel free to add them in your activity diagram. Okay, do not just include only those are mentioned. If you have more ideas or activities in your mind, do include them. This is the assignment and it's due on 27th. It don't take that much amount of time because last week we have already completed the concepts of how to create various UML diagrams. So you must have already reviewed those concepts, I'm sure. Then there is a discussion why UML, okay, which need to be completed by 25th of this month. And based on the technology stack presentation that we went over, there is another one discussion as well, which is also due on the same date, 25th. So you have 3 different homeworks to complete. There is another one thing. Let me first complete our last presentation of this chapter. Then I'll tell you what to do next. Here comes your microservice architecture. Okay, microservices. So before that, let's see what is a software service. What is a software service? You already know that. You must have some idea. So it means that a service provided to you by a service provider that make available, display, run, access, otherwise interact directly or indirectly with the products. Software services may be provided through internet or a private network and through an outsourcing company or by means of a hosted server. Your Netflix, okay, where you watch your TV shows, documentaries, movies, or Netflix is a software as services company, SaaS, that tells software to watch the licensed videos on demand, and it follows the subscription based model. So monthly there is an amount, right? So you need to choose a subscription plan and pay a fixed amount of money to Netflix monthly or annually. Your Google app is also an example of software as a service in cloud computing. The software services are actually accessed through its published interface, and all details of the service implementation are actually hidden. Your modern web services, some of the web services, your XML based tools, SOAP, WSTL, what are these? Your web services include any software application or cloud technology that provides standardized web protocols, like your yeah, sure, Derek. When I will complete, you can just stay in the meeting, then we can talk about your issues. So your web services include um, any software application or cloud technology that provides the standardized web protocols, HTTPS, or your, give me one moment. So using those HTTPS or the HTTP web protocols, you can communicate, exchange data messaging. So usually you use this XML, extensible markup language based protocol throughout the internet for that purpose. So a key feature of web services is that mostly the applications can be written in various languages and are still able to communicate by exchanging the data with one another through a web service between the clients and the server. There are different types of web services. One of them is your XML RPC. Let me annotate it here. It's not mentioned. So your XML RPC for your remote procedure call, XML remote procedure call. It is a type of XML protocol to exchange data between variety of services. Derek, could you hold on for some time? After I complete this chapter, can we talk about your question? Is it fine? Yeah. Actually, I'm getting distracted by the pop-ups of the chat window that is appearing in the screen. Okay, just hold on. It won't take more time. More time. Just stay until we end the session, and then we can talk about your issues. So your XML RPC, it uses the HTTP to easily transfer the data, and communication of other information from your client and server. Then there is UDDI, so Universal Description, Discovery and Integration. This is also another XML based standard for detailing, publishing and discovering the web services. Then you have SOAP, which will be we will look into it in more detail later in all our additional advanced slides. So SOAP is actually again XML based web service protocol to exchange data and documents over the HTTP, and there is another one protocol, SMTP, the Simple Mail Transfer Protocol. and it allows the independent processes operating on various systems to communicate using the XML. Then there is REST. REST. So it which will be also um, be looked into in more detail in the later slides, and it provides the communication and connectivity between the devices and internet for the application programming interface based tasks. And most RESTful services, web services, use HTTP as the supporting protocol. Next, your microservices. So, microservices is a service oriented architecture pattern wherein applications are built as collection of various smallest independent service units. They are small scale stateless services having a single responsibility, and they are combined to create applications. So that for creating a single application, there can be multiple small microservices. Let's look into one example. For this, here is the figure for authentication feature, functional breakdown of authentication feature. So considering a system that uses authentication module, uh, it provides the features as shown here, and each of the feature could be implemented as a separate service. You can call them microservice. And they use a single shared database to hold the authentication information. However, these features are too large to be microservices. And to identify the microservices that will be used in this authentication system, you need to break down into smaller coarse grained features into more detailed functions. So, each of the functions shown in this figure here, maybe a user registration or authenticate using UID or password, they could be implemented as a single microservice. And however, each microservice has to manage its own data, and as shown here in this slide. For the authentication microservice, so it can have it can manage its own data in this way. So individual data management is ideal for data consistency and balanced data duplication or replication. So this figure here, it shows the microservices that could be used to implement the user authentication. Uh, so these all for authentication, the UID management, password management, user info management, the round edged rectangles, they are actually your microservices. And the terms in the elliptical signs, they represent the service data. So UID management microservice will have its own UID service data. Password management microservice will have its own password service data, and user info management will have its own user data. So these are the various microservices for the authentication function. Next comes your microservice communication. This is again necessary. So services, whenever you have a web service, microservice, the services return a response to service request messages. An authentication service may send a message to the login service that includes that may be like the name input by the user, and the response may be a token associated with a valid username, or might be an error saying that there is no registered user. There are two terms again, cohesion and coupling, and the microservice characteristics. A well-designed microservice should have high cohesion, low coupling. So cohesion, it should be high. What is this cohesion actually? Cohesion is a measure of number of relationships that parts of components have with each other. High cohesion means that all the parts that are needed to deliver components functionality are included in that component. And coupling is a measure of number of relationships that one component has with other components in the system. And we need low coupling means that components do not have many relationships with each other components. And as you know, as I already mentioned, each microservice should have a single responsibility. It should actually only do one type of function and should do it well. So here is one example for user functions. So uh, in this function, the responsibility doesn't always mean a single functional responsibility. Here you can see the range of functionality might be included in a password management microservice. So for every user functions, there are supporting functions as well. Okay. Microservice architecture. Okay. As we are learning about the microservice architecture, microservice, we need to pay attention to their architecture as well. So it means that what type of architectural style is adopted for developing applications. The microservices allow a large application to be separated into smaller independent parts. And to serve a single user request, microservices based application can call on many internal microservices to compose its response. So architectural style here for microservices should address some of the problems for some applications, such as the whole system must be rebuilt, retested, redeployed whenever a change is made. It could be properly done. This type of feature must be provided in the microservice architecture. So as a demand on the system increases, the whole system must be scaled up even if the demand is localized to a small number of system components. Then comes benefits of microservices architecture. Uh, so the biggest pro or benefit of this is that the teams can develop, maintain, deploy each microservice independently because they are responsible for a particular certain type of task. And application composed of microservices scale better. You can scale them separately whenever it's necessary. They have better fault tolerance, failure tolerance, and easier to maintain and debug as well than in comparison to a complex application. Here we are going to look into a photo printing system microservice architecture. Here is the explanation for that. You can refer to it. How does it look like actually? What do we have in that system? The microservice architecture, here you just separate services for each area of functionality based on the case study given in the previous slide. So this diagram here is a possible high level system architecture for our photo printing system. You see this API gateway, application programming interface gateway. It is an important component which insulates the user app from the system's microservices. These are all the microservices. The gateway is a single point of contact and translates the service requests from the mobile app into calls to the microservices used in the system. So the app, it means what? The app doesn't need to know what service communication protocol is being used, and it also means that it is possible to change the service decomposition by splitting or combining without directly affecting the app. So for registration, there is a service. For authentication, there is a service. So upload, there is a service. So for each of the responsibilities, there are different microservices. Then the things to consider during the microservices architecture, these are pretty straightforward as mentioned here in this figure. You can look into it on your own. Mm. Then comes service communication. This is an important concept. So when you are designing a microservice architecture, you have to establish a standard of communication. Okay. So there are some of the concepts such as whether service interaction is synchronous or asynchronous. This is what we are going to look into. Apart from this, um, whether the services communicate directly or through a broker software. And then third one, if the protocol should be used for messages exchanged between the services or not. So let's look into the synchronous and asynchronous microservice interaction as shown here in this figure. Uh, there are two processes, A and B. We are using for both of the scenarios, for asynchronous and synchronous. In your synchronous interaction, your service A issues a request for service B. So service A actually suspends processing while B service is processing the request, and it waits until service B has returned the required information before continuing the execution. Okay. Service A has to wait for any type of dependency which is applicable in B. Then in the asynchronous interaction, the service A issues the request that is queued for processing by QB, and service A then continues processing without waiting for B, unlike your previous case, synchronous case, to finish its computation. So sometime later, the service B completes the earlier request from the service A and queues the result to be retrieved by A. And service A therefore has to check its queue periodically to see if the result is available. So service A doesn't have to wait for the B's processing. That's what asynchronous is. Mm. Then next type is your direct and indirect communication by broker. So direct communication requires that interacting services know each other's address, and the services interact by sending the request directly to these addresses. Whereas the indirect communication involves naming the service that is required and sending that request to a message broker, and the broker is then responsible for finding the service that can fulfill the service request. Mm. Next concept is about the data designing aspect of microservice, which is somewhat, uh, I'm not sure whether you are familiar to the acid properties, and that is your atomicity, consistency, isolation, and these for duplication, I think. Yeah. So these are the terms associated with database systems concepts. So inconsistency management, uh, in your database microservice data design, a database is always consistent in the event of some kind of failure. There are no partial updates to the data. So let's say if you are moving money from one account to another account in the same bank, it would be unacceptable for one account to be debited without crediting the same amount to the account B. So when you use your microservice architecture, this kind of transaction is difficult to implement efficiently unless you can confine the data involved in the transaction into a single microservice. So, however, it means that you need to break the rule of microservice having a single responsibility. Consequently, if you are implementing a system such as banking system, where the consistency is a critical requirement, you should normally use a shared database structure. Then the other concepts, such as, let me see. Okay. So let's look at, we can continue this chapter. Let's continue this next week as well. So before that, if you can try to read the content from the book as well, for the rest of the concepts in microservice architecture chapter content. And then the next class we will complete this and also start another one new unit as well. So